Okay, today we're going to talk about the asterisk method. The first thing I have to talk about is this shirt. You'll have to bear with me. It is Hawaiian Christmas Day at school, so sorry about the shirt. But now back to factoring quadratics, okay? Basically what we're looking at here is an x squared plus 7x plus 12. So this is going to be a quadratic where we say that the a, or the coefficient on x squared, is 1. It's a little simpler when we're dealing with this case than cases where a is not equal to 1, or the coefficient in front of x squared is something other than 1. But in this case, we're just going to step through with the basic example, and then we'll progress as we go. So here with x squared plus 7x plus 12, again, my goal is to turn this into two things that are being multiplied together to get this x squared plus 7x plus 12. So we're going to go from a quadratic trinomial, and we're going to turn that into a product of two linear binomials. Okay? So the first thing that I'm going to do for the asterisk method is set up what we call our asterisk. Okay? Very similar to your normal asterisk, except it doesn't have that vertical line in it. And we can fill out all but two parts of this right when we start. The first thing that we just read from it is whatever the first term is going to go on the top left here and on the top right. Okay? The top center is actually going to be the product of the first thing and the last thing. So 12x squared. And then last but not least, the thing in the middle goes on the bottom. So again, I took whatever my first term was in x squared, and I put the whole thing here. And I also put it here. Down here, I took my second term, the term on just x, or the term with the x involved, and I put it down here. And then on top, I multiplied the first and the last term together to get a 12x squared. Okay? So this setup, I really haven't done anything, and that's how it is every time. Now is the first time I'm really going to think. I want to think what's going to add to 7x and then multiply to 12x squared. So if I start thinking about the factors of 12x squared, or more importantly the coefficient 12, I've got the factors 1 and 12. I can do 2 and 6. I can do 3 and 4. And if I kept going, I'd repeat the list inverted. So it would be 4 and 3, 6 and 2, and 12 and 1. So I've listed all the factors here. Here's all 6 of them. And now what I'm looking for is two factors that add to 7. Well, right here on the bottom, I can see that 3 and 4 we're going to add to 7. They're also going to multiply to 12. So that means that 3x plus 4x is going to be equal to 7x when I sum it, and it'll be equal to 12x squared when I take the product. So now I have my asterisk set up. What we're going to do at this point is now we ignore everything except for these two sides. Okay, I'm going to look at this, and I'm going to look at this, and now I'm going to simplify them as if they're fractions. So I have an x squared over an x. I can simplify an x on each term, and this is going to become an x on the top and just a 3 on the bottom. When I do that, that's going to turn into my first factor. X on the top, 3 on the bottom, tells me it's x plus 3. Similarly over here, the x squared and the x are going to simplify. So I'll have just an x on the top and just a 4 on the bottom. And that's going to give me my second term, x plus 4. And now we can see if we were to FOIL this back out, we can always FOIL to check our work. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is just 12. And when I simplify the like terms in the middle here, I'm going to get x squared plus 7x plus 12. And if I come back up here, that's right where I started. So I got back what I wanted to. Therefore, the factor form of x squared plus 7x plus 12 is x plus 3 times x plus 4. Okay, so in this example, we're going to step up to a value of a that's not 1. In this case, it's 12. So we're looking at as 12x squared plus 23x plus 10. And again, we're trying to factor that into two linear binomials. We're going to use the asterisk method, where literally I can fill out 4 of the 6 spots of my asterisk just by visually inspecting and taking information from the function that was given. Okay? So basically, when I set up my asterisk now on 12x squared plus 23x plus 10, following the same rules that I did last time, in the top left is just going to be whatever my first term is, 12x squared. Top right is also the same, 12x squared. Okay? The top middle term is going to be the first term times the last term. So here the first term is 12x squared. The last term is 10. So 12x squared times 10 is 120x squared. And then finally down here in the bottom is whatever my middle term is in its entirety. So here I have 23x. So now I want to be thinking, what multiplies to 120x squared but adds to 23x? The nice part is I don't want to go listing out all the factors of 120. There's a lot of them. But I want to think about they're both positive and I need them to add to 23. Well, right now 12 and 10 being 120, that's 22. I'm pretty darn close. I don't want to stray too far from that. So let's say I have 10 here and 12 here. 10 I can visualize as 2 times 5, and 12 is just 2 times 6. Okay? So I have 2 times 5 here and 2 times 6 here. What I'm going to do is I'm going to swap some factors. I'm going to take the 2, bring it over here, and then I'm going to take one of the 3's from the 6, or one of the 3's, the only 3 from the 6, and bring it over there, but I'm still going to leave a 2. So in other words, I have 5 times 3 on this time, which is 15. Over here I took a 3 away, so I'm left with 2 times 2. But then I brought this other 2 over, so that gives me an 8. 15 times 8, if you check it out, is 120. And 15 plus 8 is going to give me that 23 that I wanted. So I'll put 15x on one side, 8x on the other side, and now I'm just going to do my reducing. And again, I'm focusing just now on these 2 side pieces. And when I reduce them, they're going to reduce down to my factors. So on this side, I have 12x squared and 15x. So an x squared and the x are always going to simplify. So I will be able to reduce that down. And now I have 12 and 15. I can see that both of those have a common factor, a greatest common factor of 3. So when I go do 3 into 12, I get 4 out. And 3 into 15, I get 5. Okay? Similarly, on this side, I have an x squared and an x. Again, one x can simplify with the x down here. And now I have 12 and 8, which are both multiples of 4. Their GCF is 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. And now I have both sides in reduced form. So I'm just going to put them together as the factors. Over here I have 4x on the top, 5 on the bottom. So that tells me my first term is 4x plus 5. And then over here I have 3x on the top and 2 on the bottom. That tells me I'm at 3x plus 2. And again, I can always check this by FOILing it out. Double distribution, if you want to think of it that way. We're going to take the first term and distribute it to everything over here. So 4x times 3x is 12x squared. 4x times 2 is going to give me my plus 8x. Okay. 5 times 3x is going to give me a plus 15x. And then 5 times 2 is plus 10. I have like terms in the middle that I can gather together. And I'm left with 12x squared plus 23x plus 10, which is where I started. So I've done everything properly.